right, ladies and gentlemen, welcome back. I hope you all are energized and not sleepy at all after that session, after that lunch, because we have a very interesting session coming up, and the topic is going to be jet-powered flight and beyond, an air mobility journey. I would like to introduce Andrea Giannini, co-founder and CTO of Exovolar, to come on stage and do his keynote. Thank you.
Millions of years ago, we started walking. Thousands of years ago, we learned how to ride horses to move faster. And about 2 centuries ago, the first motor vehicle was invented. But it wasn't until December 17, 1903, when 2 startup founders, underfunded and underrated, changed completely the meaning of transportation as we knew it. It was in 1892 when Wilbur and Orville Wright decided to open a small bicycle shop out of Dayton, Ohio. At that time, the bicycle business was booming, so they thought maybe we can make a little bit of money if we produce our own bicycles and our own products. Things were going really well, but after a few years, something changed in Wilbur's mind. He started looking at the sky and started thinking, how inspiring would it be if we had the superpower of flight? The topic of flying was not a new topic at that time. Well, the French were already flying with blimps since decades before. And also at the beginning of the 20th century, people were expecting some advancement in technology. Electric cars were already a thing, but that's another story. The thing that was yet to be demonstrated was a heavier-than-air aircraft that was able to carry the weight of a person under its own power. The so-called aerial navigation problem. People were able to hover for a few seconds, but no one was able to steer in midair. So Wilbur Wright started looking carefully at birds. He thought, well, they've flown since the dawn of time, and it looks so easy for them. And that's when he had an amazing idea. Maybe they are able to steer in midair by tilting their wings. Maybe it's by tilting their wings that they are able to control their trajectory. So he went back to Orville and he convinced his brother to build a small kite. Kites were not a new thing again, but the difference between their kite and others was that they used strings. They connected strings directly to the wings. And the idea of Wilbur's Wright was to actually try to fly and pull the strings to see if actually tilting the wings was the key to solve the aerial navigation problem. And they were successful. They did a first few trials on a very small kite. And after a first few trials, they decided to build a big version of the kite, this time manned. So it was the 1902 when Wilbur Wright jumped from a hill inside his kite. And unfortunately, disaster struck. Wilbur Wright hit his head and he was severely injured, but he didn't give up. The Wright brothers didn't give up. The problem was that in order to test the controllability hypothesis of Wilbur, they had to build a big kite, jump from a hill, and hope that he was right. There was no computer simulated environment at that time. So Orville Wright had another great idea, and I want to underline the fact that Orville Wright had 3 years of high school education, no engineering background, no college degree, and I don't think even aerospace engineering was a thing at the time, and he was able to revolutionize the world of aerospace engineering. He decided to build a small wind tunnel out of wooden boxes and a 30-horsepower fan. And he discovered something that, again, revolutionized the world of aerospace engineering. That's something that every aerospace engineer knows today. He realized that the controllability of a craft does not depend on the size of a wing. It just depends on the shape of the wing. And that was really an amazing step forward because that meant that they could have tested, they could have run more tests on a small kite, trying to tweak the shape of the wing until they reached a level of controllability that was suitable for Wilbur to try again. And that's what they did. So after a lot of trials, they decided to rebuild the prototype they destroyed the year before. And in December 17, 1903, Wilbur and Orville Wright stepped on the sandy beach of Kitty Hawk, North Carolina, and they flew for 12 seconds on the first airplane ever made by humankind, changing completely the meaning of transportation as we knew it. I want to say that their life was easy after that, but the truth is that it was still very hard. As two startup founders with a very small prototype, it was very hard for them to get funding. They tried to raise an equivalent of $5 million of today money, but no one believed them. They didn't want to show their prototype. They didn't have a patent yet. People started calling them liars. Newspapers started calling them liars, but they didn't give up. Finally, it was President Roosevelt that heard about the Wright brothers, and they decided to pay a small pilot project for the military. It was about probably a tenth of what they were asking, but still, they had a pilot project with the US military. And finally, it was in the 1908 when Wilbur Wright flew from Le Mans, France, for the entire world to see. Today, we have more than 100,000 flights per day. All thanks to two startup founders with no funding, just using their savings and what they made out of a small bicycle shop in Dayton, Ohio. I decided to co-found Exovolar because only thinking about flying makes me want to do more. It inspires me to push beyond the limits of what we believe is possible. Now imagine what we could do if we had the superpower of flight. Up until this point, we were constrained by gravity. We built everything around us being constrained by gravity. Being able to fly will unlock our abilities to design and perform beyond our own imagination. And that's why at Exovolar, we build exoskeletons to make people fly. And our vision is to make our technology accessible to everyone. But let's go back, let's say, a couple of decades. So I grew up in the south of Italy, and I grew up very passionate about the world of electronics, and mostly playing video games. And I still remember the day when I opened my first computer case. What really fascinated me, and what still fascinates me still today, is how something so complex and counterintuitive that can be an ensemble of wires, printed circuit boards, and all the little black boxes that are integrated circuits can create something so intuitive and easy to use that is a desktop computer that even a kid with little to no training at all can learn how to use in a few minutes. So I decided at the time that I was going to spend my entire life understanding how a computer worked. And I ended up being a computer engineer. I have a bachelor and a master in electrical engineering and computer science. I worked at CERN in Geneva. I worked at ETH in Zurich. And after my master, I moved to ETH. In Zurich, I was working on computer architecture for deep learning, but I was working very closely to the office of Raffaello D'Andrea. Raffaello D'Andrea was the founder of Kiva Systems, also a professor at ETH. Kiva Systems was one of the very first robotic company that were able to automate the process of inventory in factories. So they were able to do it faster and cheaper. Well, the company today is known as Amazon Robotics after they got acquired. So at that time, the group of Raffaello D'Andrea was working on unmanned aerial vehicles. It took us millions of years to go from walking to riding horses, thousands of years to get to a motor vehicle, and then to get to a flying vehicle. And now we have systems, we have machines that can fly themselves with no human input. That was really mind-blowing for me at the time. I remember that I also discovered, at the same time, I still remember the day when I watched the video of Richard Browning. He's the founder of Gravity Industries and his chief test pilot. I still remember the title of the video was How I Built a Jet Suit. And that's when I saw an opportunity. The problem with current jetpacks and jet suit solutions is that they are very hard to learn how to use. They still require hundreds of hours of training time to reach a level of controllability that is suitable enough to fly untethered. So I thought maybe there is a way to apply the advancement in control engineering and robotics to the world of jetpacks and jet suits to make something that is easy to use and accessible to everyone. So fast forward 2 years, and I decided to co-found Exovolar. I still remember, I was in Palo Alto, California. My previous company I was working for was about to get acquired. And after working at CERN in Geneva, at ETH Zurich, and in Palo Alto, I learned mostly two things. The first one is that no one knows everything. Even the smartest people in the world do not know everything. What's really important is to know what you don't know. If you know what you don't know, well, you know what are the topics you should dig into to expand your cultural baggage. Or better, you know what kind of people you should surround yourself to help you move forward with your vision. And the second thing that I learned is that it really doesn't matter how big of a group you work with. It can be 10 people, 50, 100. A single person with the wrong attitude can bring the morale down of the entire group. For those two reasons, I decided to be a founder. But of course, I knew I didn't know mechanical engineering. That was also not my passion. So I started looking for a co-founder. And that's when I met in New York Wan Wu Hao, which is my co-founder. He's a mechanical engineer, and after I took the first flight, we started talking about the possibility of applying the advancement in control and robotics to the world of jetpacks to create something accessible to everyone. And after I took the first flight, I took the second flight from the West Coast to the East Coast, then the third flight, and after the fourth flight, I decided to stay. When we co-founded Exovolar, and this was August 2020, well, the company existed in 2019. But in August, we realized mostly two things. First of all is that human dexterity is needed where it is hard for us to reach. Every year, hundreds of people die on the battlefield and in disaster zones because they cannot receive medical attention on time. And the second thing that we realized that the reason for it is that mobility enabling technology from low to mid altitude is very limited. Today there are places, and there will always be places, where helicopters cannot land nor take off. In those situations, jet suits can literally save lives. But the state-of-the-art jetpack technology does not allow to use your hands. And when evacuating people from a burning skyscraper, being able to use your hands can be the difference between life or death. So we started looking at the past, and we realized that the military, especially from the United States, tried to deploy jetpacks and jet suits since the 60s, the 70s. The problem, though, is that the current state at the time of electronics and technology in general was not suitable enough to be deployed on the battlefield. But there's still demand today. After starting working at Exovolar in March of 2021, the Defense Advanced Research Program Agency published a bid for an individual lift device, how jet suits are called, for search and rescue, reconnaissance, and first response. So we started looking at the state of the art, and we realized this is Gravity Industries. I chose Gravity because they are the pioneering company in the world of jet suits, and also because it's one of my favorite companies. They fly using turbojet engines around the hands. And the problem is that, first of all, it's not hands-free. Second of all, it requires a long training time to reach a level of controllability that is suitable enough to fly untethered. It requires a lot of ability from the pilot and upper body strength to keep balance in midair. So we decided that we were going to build a hands-free individual lift device. Of course, if we were to release the pilot from the burden of keeping balance in midair, we needed to find a new technology to do it. And that's when we stumbled upon thrust vectoring. Thrust vectoring is the same technology used by SpaceX in landing rockets or by advanced fighter jet applications. Well, SpaceX used it in a little bit of a different way with respect to the video I'm showing. They actually turned the entire engine around, but the principle is the same. Either you turn the entire engine around or just a nozzle, the idea is to create moments, rotational forces around the center of gravity of a system that you can use for different purposes. You can use it for stability, for instance, like in SpaceX, or you can use it for high-performance maneuver, like in advanced fighter jet applications. Now, the problem with thrust vectoring is that, well, it's definitely not something you can buy off the shelf at the grocery stores, like a thrust vectoring-enabled turbojet engine. And it's still very complex to be deployed on a small turbojet engine. There's a lot of hardware and a lot of hardware effort that has to be miniaturized on a small jet engine. So we decided to simplify it and build our own. The Exovolar version of thrust vectoring also allows to improve the stability, increase maneuverability of the system, but this time this is easy and simple to be built on individual lift devices. So we filed a patent, and we received a patent back by the United States, a utility patent, by November of 2020. After that, we started showing capability demonstrations. In one of our first demonstrations, we wanted to show that it is possible to modulate the amount of thrust produced by an engine and at the same time change the orientation of a nozzle using a single leg. What was left to do was to build the entire hardware and software around and then build a jet suit. And that's what we did. We started building our first jet suit prototype in January of 2021. We did the first test in April of 2021. Our prototype suits 4 turbojet engines, each with thrust vectoring capabilities. Can I ask if we can reduce the light a little bit? Each one with thrust vectoring capabilities, and each one with independent thrust control capabilities. That means that we can independently change the orientation of each nozzle and also the amount of thrust produced by an engine independently between one another. In October of 2021, we achieved hovering in the safety tethering system. Here, thrust vectoring is continuously adjusting the orientation of each nozzle to help the pilot keep balance in midair. And how it works is very similar to a Segway. On the Segway, when we want to move forward, we lean forward, and the wheels start spinning so that we don't fall. And by balancing of mechanical forces, the entire system starts moving forward. It's the same thing in midair, but with turbojet engine. Thanks. When you lean forward, the nozzle turns to push you back. And by balancing of mechanical forces, the entire system starts moving forward. So it really works just by shifting your center of gravity. So starting from the beginning, we decided we wanted to build a hands-free individual lift device. We filed a patent for thrust vectoring and find a technology that allows to do that. We achieved tether hovering by 2021, and now we are working on a multi-purpose prototype that will help us achieve the goal of flying untethered and secure our first customers by the end of next year. After showing the prototype privately, organically throughout our network, we received a memorandum of understanding and multiple letters of intent from different industry partners, a letter of support from the United States Air Force, a grant from the state of New Jersey, plus investment from Techstars. Now we are raising to secure our first customers and fly untethered by next year. In the long term, we want to open flight parks all around the world so that anyone can truly experience the dream of flying. For our go-to-market strategy, while working through grants with the government, we want to tap into existing skydiving and water park facilities so that they can offer a true flight experience in one of our suits to their own customers. But I want to show one more thing. Since I'm here in Dubai, I can imagine Exovolar opening the first flight park facility here in this beautiful city. Project Obsidian will be the first jet suit available to the public in 2024 by Exovolar. It is a hands-free individual lift device with thrust vectoring and adjustable engine position. Being able to change the engine position allows the suit to be suitable for pilots of different skill levels. The closer the engine are to your center of gravity, the easier it gets to fly. The more far the engine are from the center of gravity, the more performant the suit gets. Having adjustable engine position allows the same suit to be used for different pilots. With the overall goal with thrust vectoring to reduce the training time from hundreds of hours to little to no training time at all. But our vision goes beyond that. I cannot wait to see what we will do with anyone who will truly able to experience the superpower of flight. There is an entire space on this planet, which is the sky, that we will never be able to access as easily as we access the ground. Being able to fly will unlock that. In the future, we start building flying cities. We'll even play Quidditch. But the truth is that life on Earth will transcend beyond recognition when we are airborne. It's been a dream of mine to be able to fly since I was a kid, but I've been willing to bet that anyone in this room, you had the same dream at least once in your lifetime. Now imagine a world where this dream is not only just a fantasy, but a reality. We are pushing the limits of human abilities by bringing our vision to life. And when we combine our dreams with the real-world engineering talent that we bring, not even the sky's the limit. So I think this is more or less the end of a short version of the story on my end. I just want to add one more thing. The Draper Startup House, which is backed by Team Draper, just decided to invest in Exovolar a couple of weeks ago. So thanks, and I'll be more than happy to answer any question you might have.
Hello. Firstly, hats off. One of the best talks I've heard here, and great work. I just have like a few questions because not actually related. Like I'm in the AI space and I've worked on self-driving car models. So what I want to understand is, firstly, threats and safety. So for instance, you plan to offer this commercially in 2024. And you know, this is great disruption where the training time is quite low. Whereas I'm sure that people would be reluctant because if someone does not know how to handle a parachute, so is there a parachute built in? For instance, if something goes wrong, number one, what is the flying time? So for instance, is it like, obviously there would be a battery, you know, just, so is it like 30 minutes, 15 minutes? How long can I fly for? And is it charged? How does that work? Yeah, so these are sort of questions.
Okay.
Yeah.
Yeah, let's start. If I forget something, just remind me about the
Yeah,
question.
sure.
Okay. The first question was, regarding like parachute safety, right?
Yeah, safety.
Yeah.
Yep.
So in 2024, the flight park facilities that we plan on having, basically the customers will fly tethered. We are going to fly untethered by the end of next year, but it's going to be a rope. So what we have in mind is like having like two structure over water, where you can fly back and forth for 200, 300 meters. And the safety rope will provide all the safety you need. But yes, for ourselves, there will be a ballistic parachute. So the parachute, in case of emergency, will, when you fly out, will basically trigger automatically if something happens. So yes, that's regarding safety. Then the second question was about the flight time. Yes. The first prototype that we have has a flight time between around 3 minutes, but it was a capability demonstrator. Now we are targeting 15 to 30 minutes. And that connects to the thing you mentioned about batteries. Yeah. So we have a plan of switching to electric in the future. We actually are, the grant that we won was to it's part of the grant is to electrify all our prototypes by 5 years from now. And also we are partnering with a hydrogen powertrain company to do a feasibility study to use hydrogen in the future. But this is not electric. This uses Jet A. It's the same fuel that goes in airlines. And I can talk for hours why, but the reason is mostly related to the specific energy density of batteries and fuel and hydrogen. Like the specific energy density, I'm talking about literally kilogram, joule per kilogram. The joule per kilogram of batteries is 40x on average worse than Jet A. That means that for the same flight time, you need to carry 40x the weight of the batteries with respect to the fuel. Hydrogen is great because it's 3x the fuel, so around more than 100x better than batteries, but it's still not ready to be deployed. So
interesting. And last question. So I think there's a lot of play of, you know, deep learning and reinforcement learning models in this. I think you belong to that background. So what I want to understand is that, are there any sensors where you're collecting data, and do you plan to implement these sort of algorithms to ensure, like for instance, maybe predictive maintenance or threat detection, or if something goes wrong, you preempt risk? Just want to understand your plans on that. Thanks.
Yes, so the answer is yes, absolutely. AI and reinforcement learning, they definitely help, especially, like for instance, the advancement in control engineering and robotics now allows us to fly hands-free already. But one thing that, for instance, AI can be really helpful in the future is to actually predict where the person will shift his center of gravity. Like you can track the movement of a person. So even before that happens, the nozzle turn in a certain way to counteract that movement. So definitely, AI will play a crucial role in the future for us too. Any other questions? Yes.
Andrea, great talk. Congratulations. Also, congratulations on investment by Draper.
Thank you.
Yeah. So I'm going back to some basic questions. So naturally, human body is not designed to fly. Yeah. So it's designed to walk. It's designed to have a support underneath. So what kind of like you certainly have experience on the end users who are using your jetpack right now. What's the feedback and how does it being perceived? Because it's not natural for human body.
Yeah. I don't remember last time I've flown, so yeah, it's
exactly.
Yeah, it's not that easy. So yeah, and that's where the exoskeleton and thrust vectoring comes into play. It is very hard to use jetpacks and jet suits today. And the reason is, as I mentioned before, you need a lot of upper body strength for gravity, and you need a lot of skills for yourself. Like it takes hundreds of hours. It is not a number that this is a quote actually from, I think from Richard himself. To reach a level of controllability suitable enough to fly untethered. And that's where thrust vectoring comes into play, and also the exoskeleton himself. Like, for instance, now you feel the push of the jet engine, especially in a gravity suit. Instead, thanks to the exoskeleton that basically carries the weight of the backpack, you don't have to carry it himself. It's actually carried by the push of the engine himself. So it's all the weight all goes down to the engine. It will feel like you are in an elevator, maybe a fast elevator. Okay. So you don't feel the weight of the structure around you. You feel the acceleration a little bit for sure. And actually, quoting my CEO, it really literally feels like walking on a cloud. We were expecting like to have this abrupt feeling. Instead, it's not that abrupt if you tweak in a certain way the thrust vectoring system. So, so yeah, that's basically how it will feel a little bit more natural.
Fantastic. Just one concluding question. So it seems that so you are targeting it's more on sort of like an amusement side, but also on, as you just mentioned, for the first responder, or even, for example, if some construction workers going kind of like would like to be on the very upper level. Yeah. So is that kind of like which market or which type of users you are targeting until 2024?
Yeah, we are doing. We are definitely working with the government for first responders. Mm-hmm. Well, it takes some time to work with the government.
Definitely, so. Definitely.
So yes, they especially in the United States Air Force, they want to use it for search and rescue, reconnaissance, and surveillance, first response. Yeah. And so that's definitely our target by 2024. At the same time, it's entertainment, and there are different reasons for it. First of all, is that again. I think anyone in this room, but anywhere in the world, had the dream of flying at least once. And the other reason, the FAA red tape for entertainment is not that hard to get. Like, give you two examples. First one, if you fly tethered, you don't need an FAA license. I'm talking about the FAA because I'm in the United States. I think here it's a little bit easier.
Yeah.
So you don't need an FAA license if you fly tethered. So we can literally start taking customers in, as they are already our competitors, if you want. I don't like to think about competitors because the industry is so small, so we help each other out. But jetpack aviation, you want to fly in a jetpack, you can just go there right now in the US. It's a little bit expensive, but you can do a flight training for a couple of days without license. And if you fly untethered, for entertainment purpose, there is the ultralight class, which is not too hard to get. again, jetpacks, they already are FAA licensed, the one from Jetpack Aviation. Instead, if you want to do for a construction worker, and actually we gained a lot of traction, for instance, in the offshore wind industry, or since we're here, also in the oil rig industry, to do inspection and maintenance of oil rig and offshore wind turbine. Like there are a couple of, like especially for maintenance of a turbine, people still use helicopters. Like they literally strapped technicians to helicopters to do certain inspection and maintenance that, of course, a drone can't. But the FAA, like, it's really, really, really hard to get an FAA license for doing that. So that's why we're targeting first government, since I used to say they make their own rules, and entertainment, like tethered for people. Yeah.
Fantastic. Thanks a lot.
Thanks,
Andrea.
I think we have 6 seconds, so thank you again, and happy to network later on, so thank you.
An extremely interesting session, wasn't that?